As I'm getting ready to take the fuel rail apart and rebuild it, I just wanted to give you a few pictures of what it looked like when it came off the car and as I was preparing to go through it. That's the fuel pressure regulator. Um, Here's a picture of it inverted, and now we'll go into it after I took it apart.
I'm in the process of rebuilding the fuel rail. This is in order to finish the entire fuel system from tank to engine. I have new fuel injectors which attach to this rail. This is the feed to those fuel injectors, and just thought I would mention, I'm taking that apart to clean as well. The main thing that I'm worried about to disassemble is this fuel pressure regulator. It goes together like this and has a cap that sits over it, roughly like that. So if you take that cap off and you take the regulator element out, that leaves this bowl on the bottom. And kind of the point is, and this is the reason I'm going through this process, if you go into here and you look at try to get this thing to focus a little bit, see that red ring around the very center of the picture? Right about in here. That is like a dusty residue. I've knocked some of it out already, but as the gas settled and did its bad things in here as it aged, we have this this dust and grit essentially that's built up. I don't know if I can see it in a separate spot here where I had another spot on the rail where it was pretty evident. So the main point anyway is that everything, I've got carburetor cleaner. I'm going to go through and flush all the passages, all the dirt. I have a brand new replacement diaphragm for the fuel pressure regulator. What that regulator does is it holds the fuel rail at about 45 or 46 psi, and then there are two lines on here. One is one of the hoses is the feed, and the other is a return back to the tank. And so the pump feeds the rails, pressurizes the rail, gets that regulator. When the regulator gets up to its regulating point at around 45, it opens slightly and feeds fuel back to that other line, to the drain line, which goes back to the tank and gets you some circulation. So at this point, I'm cleaning the pressure side, I'm cleaning the drain side. I'm going to flush out all of these. I have a line. These cars have something called a cold start injector. It's a 9th injector on the fuel rail, and I need to flush that one out as well. And again, replacing all of the O-rings, which also have been kind of eaten out by bad fuel over the years. I had one additional challenge. I had to go to the store and buy another set of bits, but in order to take that fuel pressure regulator apart, it's something called a tamper-resistant bit, Torx with a tamper-resistant bit. And if I could get this thing to focus properly, here we go. You'll notice the one on the far right is cylindrical and doesn't have any teeth on it. That's supposed to be the smallest bit, and that was the one I needed to take the regulator apart. And instead I had to go out and buy a new one, a new set, because I just didn't have time to go send it back. And there's my replacement bit. These are unique because the screws have a pin. There's a hole in the center of that Torx bit. You maybe could see right there. And these are called tamper resistant. If you don't have the special bit, you can't take it apart in a regular Torx bit. It just slows down the number of people who will take things apart and get themselves in trouble because they don't know what they're doing. But now back to cleaning parts.
As I was rebuilding the fuel rail, I ran into a challenge I didn't expect. Um, I couldn't find O-rings from a regular parts supplier for the what they call the ninth injector, the cold start injector. These early cars had this, so you can go to AC Delco and you can buy the kit to rebuild the whole rail. But I didn't find rings that looked correct for the three O-rings that are needed for the cold start system. And when I go back and look at parts, you can look at the exploded view. Uh, GM in their parts system never called out the O-rings individually, never identified them. They were always in a kit. And when you go to AC Delco, the kit's now been discontinued. And I've checked all my normal parts suppliers and haven't been able to find a substitute. So rather than just guessing and trying to stick something in the hole that looks about right, I tried to approach this from what would the design standard be, and it's a little challenging because the whole fuel rail was designed appeared to be designed metric. If you look at the flats on the nuts, the wrenches that you use, most of the dimensions, the threads on these plugs, they're all metric because GM was in the process of transitioning to metric parts, um, which is why you'll see these crossed out parts right here, because I started looking at metric O-rings first, and they didn't seem to be quite appropriate. So just as I dive in here, I got to give my warning first, which is I'm measuring parts, I'm measuring my parts, I'm making a judgment for rebuilding this car that might be helpful to you, but I haven't tested these, they're not validated. If you want to use this information to work on your own car, check it, verify it, make sure that it's proper and appropriate for your use because all the parts are a little different. This is gasoline under pressure, and if it leaks, you could have a fire. My intention as I go through this is I'm going to select some O-rings, I'm going to assemble this, and I'm going to pressurize the fuel system very, very carefully to make sure that that the rings that I chose don't leak. And I just when you're working with fuel systems, you can't be too careful. So my intent here is to see if I can, I'll say, reverse engineer and determine what it looks like the engineers intended to have in this design in the first place. Um, when you take these apart, the other challenge is that all the old O-rings are swelled up and distorted from sitting for years in bad fuel and having been hot and so forth. So the measurements are a little um, iffy at times. Also, I'm trying to measure flexible parts with a dial caliper, and in real life, in industry, they'd probably use some kind of an optical system that I don't have. So I'm getting as close as I can with the tools that I have. The On this one, which is this large nut and the groove here, the cross section of the O-ring was between 70 and 80 thousandths. The O-ring ID that I measured was about 630 to 650. The O-ring OD was 775 to 800. It looked to me like it had swelled quite a bit. Then I went back and measured the groove here in the nut and the bore in the end of the rail. So what they call the gland ID is 610. That would be the small diameter here where the O-ring could seat on the on ID of the O-ring. The bore diameter of 715 is inside the end of the rail, and the width of the gland is 091. That's the width of this nut in here. So as I said, I went to look at metric O-rings first, and the nearest standard metric O-ring looked like it was 79 thousandths cross section, which if it swelled would have been well over 80. Um, if you looked at the O-ring ID, it was kind of too small. Um, Maybe not a lot too small, but a little bit. and and the OD is kind of close, but it just didn't look like it lined up correctly, particularly on this cross section. So I started looking at the SAE standards, which are English dimensioned and were very, very common in the industry and still are very common in the industry. Um, so if I go through and take they, if you go to O-ring design information handbooks, there are standard dimensions for an SAE O-ring and the bore, and they recommend certain O-rings going certain bore and groove sizes. And there's a design tolerance set up for if you want the O-ring to primarily seal on the OD, and there's one if you want it to seal on the ID, depending on um, whether you're using using a gland ID like this. I don't have all the pictures, but it's the configuration of how the seal would contact. So as I went through, I was trying to confirm which one was maybe more appropriate. If you take a gland ID of 625 and the actual one I measured was 610, that's pretty close. That would be the standard design for that groove. The bore diameter of 725, it's close to 715. It's 10 thousandths, and there's tolerance on this bore. I don't know which end the part was made to, so it's close. The gland width is about right, and if you look at the OD case, those numbers are a lot further away. So based on the configuration of this should be an ID seal design. And so here it is. It lines up. It's it's pretty close in dimension. The cross section of 70 is, the O-ring is probably swelled to 75, so 70 is about right. So I'm going to pick and I'm going to put in one of these 016. The SAE is a standard AS568, and then 016 is the size of the O-ring under that spec. And so there's an 016 and 70 by 614 ID. So this 614 ID will seal up on a 625 groove, and I'm expecting that one should work. Now the next one is here on this tube. I went through the same process. You can see this one's it got wider and kind of compressed a little bit in the radial direction. Um, and here were the dimensions of the ring as measured. So the tube and bore, the gland ID 188, that's the outside diameter of the tube. The bore diameter is 350, that's the inside diameter of the nut. The gland width is hard to measure because what you're trying to measure is a stack of dimensions of uh, where this nut seats and how deep this nut is here, which at the bottom is a taper. So it's very hard to get an accurate measurement. So 142 is a little narrow in the ballpark, but this definitely looks like it's probably a 103 cross-section O-ring, and the gland ID is right on the money by design. The bore diameter is right on the money by design. So I'm going to put a 106 in the car and see how that works. The last one is the top of the cold start injector itself. Uh, Again, the O-ring had swelled. Um, Dimensions were off a little bit, but the top of the injector measured 437. It'd be right across here. The the bore diameter inside this cap, or I don't know what better to call it, looked like 590 to 600. The gland width is hard to measure. I tried to get in there with something that I could use. It's you can't get a dial caliper inside there, So I went in with a piece of wire and tried to scale it and measure it to the best that I could to get close. But um, working off the trend, if um, if you pick a 111 seal off the standard chart, the design characteristic for that on an ID seal is 437, which lines right up, and 599 lines right up, and 103 is in between the measurements that I had, um, recognizing that things swelled and distorted over time. So I'm going to put that one in. And again, you know, I'm always very careful about these things because I worked in this and you need to validate designs. And and I'm making the best estimate I can of what ought to work. I'll have to see whether it really does. One last thing, I chose Viton. Viton's, I suspect they may have used Viton. It's very commonly used in fuel systems. The challenge you have to watch when you select a Viton seal is what its low temperature capability is. I know that based on the specs, that Viton seals tend to get stiff when they're cold, and fuel systems need to go to minus 40 if you're in a real cold climate. And and I don't know that uh, you probably have to special order a Viton that gets down that far. I don't think the seals I use are that good, but I also don't plan to run this car. It's going to be in the garage, and if the car ever gets below 0 Fahrenheit, I'd be surprised. So those are the three parts I chose. When I get the car together and get the fuel pump charged up, the system runs at about 40 psi. I'm going to pressurize it, and I'm going to check very carefully to make sure that none of these things um, none of these things leak. So now I need to finish getting this thing back on the engine.